Hello students, welcome to Saurav Sir's classes. The question is, an alien language has n letters b1, b2 up to bn. For some k less than n by 2, assume that all words formed by any of the k letters written left to right are meaningful. These words are called k words. Such a k word is considered sacred if option 1, no letter appears twice, and option 2, if a letter bi appears in the word, then the letters bi minus 1 and bi plus 1 do not appear. Here bn plus 1 is equal to b1 and b naught is equal to bn. For example, if n is equal to 7 and k is equal to 3, then b1, b3, b6, b3, b1, b6 and b2, b4, b6 are sacred 3 words. On the other hand, b1, b7, b4, b2, b2, b6 are not sacred. Then what is the total number of sacred k words? Use your formula to find the answer for n is equal to 10 and k is equal to 4. Now we will count the sacred words starting with b1. Since b1 is chosen and bn and b2 are out of the picture, now in order to fill the remaining k minus 1 positions, we have to choose non-consecutive bi's. Note that specifying these bi's is equivalent to specifying the gaps between them. For example, let n is equal to 7, k is equal to 3, and we would like to choose b1, b3 and b6. Then the triplet 1 to 1 specifies that leave one alphabet after b1, drop 2 after b3 and drop 1 after b6. Hence, in general, let x1, x2 and so on up to xk be these gaps. It is clear that each of this gap is at least 1 and they add up to n minus k. So our counting problem is now, in how many different ways one can choose k natural numbers, each of which is at least 1 that add up to n minus k. The answer is n minus k minus 1, ck minus 1. In fact, this is equivalent to counting the number of ways one can choose k minus 1 plus signs from n minus k minus 1 of them when n minus k is written as a sum of ones. However, note that we haven't assigned positions to these letters yet. This can be done in k minus 1 factorial ways. Hence, the answer is k minus 1 factorial into n minus 1 minus k, c k minus 1. In order to count the number of sacred words, we just need to multiply the above number, that is this, by n. So the final answer is n into k minus 1 factorial into n minus k minus 1 factorial by n minus 2k factorial into k minus 1 factorial, which is equal to n into n minus k minus 1 factorial by n minus 2k factorial, which is equal to n into n minus k minus 1 into n minus k minus 2 and so on up to n minus 2k plus 1. Now for n is equal to 10, and k is equal to 4. On solving this, the answer comes out to be 600.